Now the next thing that we have is perpendicular bisector of sides. Okay. Now here what I'll do is I'll draw the diagram so that you can see the process for once. Okay. And maybe the understanding is better. And circumcenter, right? And perpendicular bisector of sides and circumcenter. I'll draw the triangle, a simple scalene triangle. Okay. Now what I want to do is I want to draw the perpendicular bisector. Bisector means the thing that divides into two equal parts. So for BC, if I draw a bisector, it must pass through the midpoint. Remember the midpoint? This point was D. Here I want to draw a perpendicular like this. So this is the perpendicular bisector of side BC. Similarly, the perpendicular bisector of side AC, it will look something like this. Remember, this point was E, midpoint of AC. And similarly, draw the perpendicular bisector of side AB and it should look like this. So this is a perpendicular here, this is a perpendicular here. Okay, and this point is F. Now the point of intersection of this perpendicular bisectors, this point, let's call it O. This O is the circumcenter. This point O is the circumcenter. Now incidentally, in any triangle, the three perpendicular bisector of sides, they have to pass through the same point. They are concurrent. And that point of concurrency is called circumcenter. Why is it called circumcenter? Because it is the center of circumcircle. Okay. What is the meaning of circumcircle? The circle that passes through all the three vertices of the triangle. And I think you can see, if you have followed the process of making of this diagram, you can see that this dotted line or this dotted line or this dotted line, they are the radii, and that radius is called circumradius. Right? Let's call it circumradius. We have already talked about circumradius in one of the previous sessions, in fact twice. And this length is calculated as product of sides divided by 4 times area of triangle. So any triangle in general, this is the formula for circumradius. Now what is important is angle at circumcenter. Angle at circumcenter. In fact, this actually works a lot with the circle properties, right? So angle at circumcenter, that is angle BOC. Try to see that angle BOC. It is equal to 2 times the opposite angle. So this angle is 2 times the opposite angle. So 2 times angle A, right? Angle AOB, that is 2 times the angle C. Okay. Angle AOC, it is 2 times the angle B. All right. So this is perpendicular bisector of sides and circumcenter. Now once again, the fourth point, that is altitude, that is height and orthocenter. Once again, I'll try to show the process of drawing so that helps you in some questions. This is the triangle ABC. What is the meaning of altitude? The height of a point from the opposite side. So I simply drop a perpendicular from A to BC. Okay, let's call this AL. Right, you have to see that AL is perpendicular to BC, but L is not the midpoint. Okay, may or may not be the midpoint, right? From B also, if you drop the height, so this point, suppose it is M, this is perpendicular, and if you drop a height from C to AB, right, let's call it N. So here the altitudes are AL, BM and CN, and they are again concurrent and they meet at the same point. Usually we present as capital H. So this capital H point is the point of intersection of all the altitudes. All the altitudes in any triangle, they are concurrent, they meet at the same point, and that point is called orthocenter. So this H is orthocenter. Right? Now this has one very important property, that is angle at orthocenter, that you should remember. Angle at orthocenter, and it is directly calculated as, you see, angle BHC, that is equal to 180 degree minus the opposite angle, so angle A. So angle BHC, opposite angle is A, so 180 degree minus angle A. Angle AHC is 180 degree minus angle B. Angle AHB is 180 degree minus angle C. Right? There is no property of length related to this. right? Now we will talk about some specific cases. Now how do I divide the cases? Very clearly, on the basis of different types of triangles, we'll draw them. So what is their position in scalene triangle, that we'll try to understand separately, right? Relative position of those 4 points that we have talked about. What are the points? Just to revise: centroid, okay, then we did incenter, right, and then we did circumcenter, okay, and then we did orthocenter. So the relative position of these 4 points in case of scalene triangle, isosceles triangle, okay, separately, and for equilateral triangle, right, and for a right angle triangle, okay, and obviously for obtuse angle triangle, fine, and of course for acute angle triangle. So if you see, what did we do? We have already studied earlier that there are 3 types of triangles on the basis of length of side, 3 types of triangles on the basis of angles of the sides, and the position of these 4 points with respect to these 3 and these 3 with respect to the position of the triangle. We'll try to understand that.